Hello, today we'll be scripting Ghidra. So if you haven't seen my last video, it was where we solved this space fights challenge for NES emulator, and in that challenge we had to do a lot of manual memory layout management in Ghidra. So in this video I will show you how you can automate that and do it much faster and in a repeated way. So I have Ghidra open with the challenge, so the memory map is as it was in the last video. So we have just one block RAM that starts at address 0, and we want to have the result as it was shown in the previous video. So we can write a script for Ghidra, and this script will execute commands and will prepare correct memory map as we want to. So we could write a script and pass it to Ghidra and to be used from this script manager, but we can also use this Python interpreter for like quick testing purposes, and this is what I will do right now. So let's get started. So the most important thing if you are using this Python interpreter is knowledge that some global objects are available and we can use them to use in our script. So the one such global object is current program, which we can use to execute methods on it and get access to our current program, and this is mainly what we will be using today. So the first thing we need to do we need to get access to the memory of current program, and we can do it by calling current program get memory, and this is the Ghidra is in Java, so the naming convention is like camel case. So when we execute that, in memory we'll have access to the memory, and now we can do a lot of stuff. And just so I'm not saying I know all those methods by heart, there's like a documentation for Ghidra. Of course, you can go to ghidra.re, Ghidra docs API, and we have documentation here, and we can find here that there is this current program. There's also this monitor that we'll use in a moment. And for example, on the current program, if we go here, we can click, we can search here to see if there is like a get memory method, and there is, and it returns object of memory. And we can go now here and see what we have access to, and we can see that there are some like methods to access blocks, to create new blocks, and we will be mainly using that. But before we use that, we need to get access to the current bytes that we have in Ghidra. We'll be using that to move our objects, to allocate a new block in the specific address, so we need those bytes. So we'll use this get all file bytes method on the memory. So let's just create another variable that will store those get all file bytes. Okay, so now we have all the file bytes from this program, and now we can start doing our job. So the first thing, I will remove this block, so the block that we currently have. So let's just again have a variable, and on the memory will call get block, and we will pass an address. So basically toAddr is another like a global accessible function in this time that we can convert an int or an int representation of an address to actual address class that Ghidra requires, for example, for this get block method. So after that, in BLK we have a block, so now we can remove it and we'll pass this BL key. And another thing we need to pass for this method is this monitor, this global variable monitor that I think it's used for like cancellation and yeah, monitoring of the operation. We could use it to like, yeah, have some kind of progress bar, I guess. But for now we don't need it, so we'll just use it and remove the block. Okay, so now we have a clean slate, so we can start creating our blocks. So let's get started. So I don't know why I cannot type today. I think it's too early. Memory block. Okay, and we'll call it, first one was internal RAM, and again we'll use toAddr to convert 0 to an address. The length, it will be 2000 hex, and the last parameter is true or false, whether it's like a shadow block or regular one. This case we want a regular one, and we can see that Ghidra already started showing us some uninitialized stuff here, because this is the kind of block that we requested. Okay, let's create another one. Memory, create an ini block. This time it will be PPU registers. Again, address, it will start at 2000 hex. The size will be 8, and again false, as it's not a shadow block. Okay, and I made a typo. Okay, again, maybe I will just use up arrow to bring the last command and just modify it. So next one was APU, and it starts at 4K. The size is 18 hexadecimal, and again false. And we have all those 3 uninitialized blocks. So the last one will be the initialized, which we will map at 8K hexadecimal, and it will actually contains the program of our challenge. So for this one we will use another method, create initialize. Okay, nice block, and it has a bit different parameters, so we'll call it ROM. toAddr will be at 8K, because this is the address that we want to map. Now we need to pass the bytes, and that's why we save those bytes here. So we have all the bytes from the program. So now we can pass, because this is an array, because it can be more than one just array of bytes in Ghidra loaded at the time. So that's why it returns an array, but in our case it has only one element, so we'll use fb indexed 0. Then the offset in the file, we want to skip the first 16 characters, because that's the header in our case, and the length is 8K we want to map, and again false to mark that this is not a shadow block. And yeah, so now if we go to this 8K, we have our bytes, but it's not disassembled, it's just raw bytes. So the last thing we need to do, we'll call yet another global function, disassemble, and what we need to pass, again, it's toAddress, and pass an address that we want to start the disassembly. And yep, voila, Ghidra will start disassembling our code, and yeah, we have all those blocks correctly mapped, no issues, no red squigglies from Ghidra. And if we go to manager memory map, we can see all those blocks as we did before in manually, and now we can also automate that in Ghidra. So this is everything you need to actually script Ghidra, just knowledge of few functions which you can find in this documentation at ghidra.re, and then just need to find the correct method that can do what you want to do to automate Ghidra. And we can save this in a file and then have access from the script manager and then execute it. Or if we, for example, use this headless mode, we can also pass the script to a headless mode and yeah, do the analysis automatically when Ghidra loads the file. So yeah, that was it. That was a short one, but I hope you like it. Yeah, now we can know how we can start automating Ghidra, and yeah, let me know if you want more of such videos, and if you like, yeah, please hit the like button and subscribe, and see you next time in one of the videos. Bye bye.